Program weekdays 11 a.m. to 2 p.m. on WCPT 820, where facts matter. Alexa, play WCPT.
WCPT from TuneIn.
You are listening to Think Theory Radio. Radio.
Hello and welcome to Think Theory Radio, the show that brings you topics outside the mainstream realm of thought and ideas to make you think. And I'm your host, Damian Perdue, your cosmological guide on this universal ride of quantum delights. And of course, I'm joined by Paulie C.
Yo.
Or I'm rejoined by Paulie
Rejoined,
C.
yeah. No one needs to know.
Once again joined by.
Maybe they're, there you go. Yeah, once again. 'Cause no one needs to, it's not out of sequence. You can listen to
You
Think
never
Theory.
know.
Yeah.
I mean, unless you're an avid live listener.
Oh, then you know.
Then you know.
Yeah, Paul's back.
If you know, you know.
Yep. If you know, you know.
And if you know about the universe, you know that you don't know anything.
No, I don't know anything.
And
about the universe,
anyone, generally speaking, not a personal you.
No, I mean me personally.
Nobody really knows.
I mean, I don't want to date this thing, but like, I was really impressed that like the Artemis 2 mission, the most impressive thing about the whole thing to me was the fact they knew what minute they were going to land way before they even launched.
Yeah.
Like, that's wild to me. Like, down to the minute.
Yeah. I mean, you got to be that precise when you're doing, flying through space.
I mean, it's not rocket science, but I guess it literally is.
That's the one time you can say it is rocket.
Yeah, it is rocket science. But no, as far as the universe goes, I don't know anything.
And most people don't really know.
It's like
even
kind
those
of
who know don't really know.
Well, I was thinking about even with that mission, the moon. Like, how do you the moon's always like moving around the Earth, so it's like you got to time it right there. I mean, what if you overshoot it?
Oh yeah, well that's always a possibility. But
yeah.
That's why you got to tie in all the factors of gravity and the curve and like the whipping by. I forget what that term is. Like the.
I saw a graphic of how like the sun is moving in space and how all the solar system planets move around it, and it's like, you grow up thinking it's so two-dimensional, but it's incredibly three-dimensional how it happens because the sun is hurtling through space, and all these things are still moving around it, however it does. And
I know that I think you grow up thinking that it's static. That the planets are moving, the Earth is rotating.
Yeah, but you don't think about where the sun's going.
Yeah, you don't think that we're all just following along. The sun is just on its own journey, and we're just tagging along, really, because it's such a massive force of gravity that we're just, holding on, and the sun's just doing its thing. It's, flying through the galaxy, and we're just stuck with it.
Yeah.
If so one little thing. That's the crazy thing. It's like how fragile it is too. One little thing that knocks us out of the force of gravity of the sun. And, we're done.
Yeah.
We freeze to death.
That's
I mean, just one little beep.
I think they said you have like 8 minutes from like the time that the sun
if we moved out of
I mean even like the I was thinking of like if the sun burnt out, you have like 8 minutes or something like that.
But it's essentially the same thing. Like if we moved away from the sun, or if we stopped rotating, and you just had one side of the Earth would just go extremely cold.
Well, but then if the Earth stopped rotating, wouldn't there be no gravity?
And we'd all just fly off.
I don't know.
Well, no, gravity exists because they're like.
I think that's only if it gets to a screeching halt, we fly off. I think we just float
I don't know.
off.
It
depends.
That's beyond my understanding.
Yeah.
Because I mean, gravity still.
This isn't what the show is about, though.
It kind of, in a way, it is because this is today's topic is new theories on the universe.
Okay.
So it ties in.
Gravity and I'm thinking hyper local here by talking about the moon, though. I didn't want to do that. It's just so it's time relevant. But then I didn't want your show to get derailed where everyone's calling in talking about, oh man, gee whiz, Artemis was so cool.
Right. I had the strangest interaction with a stranger, like the day that they launched.
Yeah.
Just some random guy walking down the street, but he was very like, kind of seemed like a movie character. He was like Russian or Ukrainian and something. His name was Hugo. He just came up to me. He was like, "Hey man, how are you?" And he had like those big like European sunglasses on, and he had kind of like a furry coat.
Okay.
And he had like the Uncle Sam pants, like the red, white, and blue pants on.
Okay.
You know, and he was just very, you know, like he had that accent, you know, like, "Hey man, how are you?" You know, I was like, "Oh,
You
I'm
ran
good."
into an SNL sketch from the
And for real,
70s.
it was so weird. And he's like, "Yeah, what? So
Just looking for a cool time.
when he started talking about Artemis, he's like, "You know, they're going back to the moon today." And I was like, "Oh well, they're going around it. You know, they're not landing on it yet." But he's like, "Yeah, but it's amazing." And he just turns. I was like, "No, totally, yeah."
Amazing to think that that's the furthest that ever a human being has ever been away from the Earth. You know, even though it's relatively close to where we've already sent people. You know, but that's still pretty cool. And I liked how they were like, "We choose this moment to, you know, challenge the next generation to beat this record." And but I thought about it just from the get-go once they said they were going to the moon. Just the idea that like this is the first time in my lifetime that we're going to the moon.
Yeah.
You know, like I grew up
In a
hearing
lot of people's lifetimes.
Yeah, and like, you know, grew up hearing about that, you know, so it's like, you know, I'm not a young buck, you know. It's
Right.
been a long time, so it's kind of cool to see that happen. But and then just the neat to see even in this day and age people still kind of like watching it live together to see the highlights, you know, they're surrounding the moon, they're launching, they're especially the landing. You know, everyone kind of just holding their breath for a second as they're going through the atmosphere.
I saw a video of from a film from one of the Apollo missions. I don't know if it was the first one or not, but it was at the White Sox game.
Oh yeah, yeah.
Did you see that? And they were like, everyone was like counting it down at the game.
Was it the one with the commentator? There's
I
like
believe
a
so,
okay,
yeah. And there was like a band playing.
Yeah,
and everyone,
yep.
You know, that was kind of cool to see those kind of like worlds merging. You know, and how important it was that people were at a baseball game. And they're like, you know, hey, stop. We're gonna watch this.
Well, one of my favorite baseball oddities was it the moon
Spaceman?
landing? No, the Alvin Dark, the manager for the Giants, was asked like early in the 60s, like, will Gaylord Perry hit a home run? Gaylord, they'll put a man on the moon before Gaylord. Yeah. I guess Gaylord Perry homered that night.
That's so crazy.
There's his first home run, yeah.
Nice.
Yeah.
See, it all ties together.
But the universe, though.
The universe,
New
man.
theories about the universe.
New theories about the
So,
universe.
I mean, what are the going theories about the universe? Like the universe is expanding, or we're in like in some cat's collar, according to Men in Black, or what are we talking about here?
Well, so, you know, basically what most people understand is the Big Bang, right? And there was, you know, we come from a singularity where all matter and energy in the universe was, you know, compressed into a tiny little particle that everything was in, and then just exploded out into the Big Bang, which happened later. We don't really know what happened before the Big Bang exactly. And then there was a period of rapid inflation that wasn't as fast as the Big Bang, but it was still pretty fast. And then it cooled off and kind of and became the universe that we know. And now, and it's just, and then theories about expansion. This is, you know, and a lot of this is within the last 100 years, right? And for a while, they believed it was static, and then figured out, oh, wait, no, that the universe is actually expanding. Then it was rapidly expanding. But now there's new evidence from like the DESI telescope, which we'll get into a little bit, but that's showing that it's actually slowing down. So because of this information, it's challenging beliefs about dark energy and dark matter. And then there's a bunch of other, I think some of these are kind of reimaginings of old theories, or working on these old theories with new information, because now with like the James Webb Space Telescope and these other telescopes like the DESI one, there's one in Chile they're building that should be, or I think it's already built, and I think they should be getting information from it this year. But you're going to get new and more information about the early days of the universe. And then with these massive like supercomputers, and they're running models all the time. They're using AI now. And like AI hasn't really come up with any of its own theories, but it's done a pretty good job.
Programmed it to know anything yet. They,
The interesting thing is they put in a lot of big AI models, they put in just without prompting it, without giving it any information more than it would know, or more than we knew when we first figured out kind of the beginning stages of the universe, it figured out the same thing. So like without the scientists telling it, hey, this is what happened, this is the Big Bang, it figured out the same thing. It came up with the same numbers, the same statistics, the same set of variables.
It had to have like a similar starting point though, right?
Yeah, I believe so. I mean, they had to give it some kind of information, but they didn't, explain to it exactly how everything happened.
And it kind of landed on some of the See, here I thought maybe AI was just like being stubborn because it was offended by, they thought Stephen Hawking was mocking them or something, the robots.
Why does it talk like that? I don't like that.
Yes.
No, but there's like little by little, I've been seeing these articles with different scientists proposing different theories. So I just kind of started gathering them and thought it'd be an interesting one to kind of talk about the different ones. Of course, there's some kind of far out ones like this first one, because any time a scientist says reality is an illusion, I'm all for it. You know that.
Sure. Yeah. I mean,
that's right.
I mean,
right in my
for reaffirmation, or you just like along for the ride, or
just like that this none of this exists,
or just like hey man, I'll believe anything now.
Right.
After COVID, it was just like someone spilled coffee on the computer writing the story here. Yeah.
Does not compute. But
it's just everything.
This theory is kind of, like this is one of the ones that's kind of based on other theories, but she's proposing a new way to look at things. Okay. And her name is Maria Strum. She's a professor of material science at Uppsala University. And in her framework, consciousness exists first, and then time, space, and matter emerge from consciousness.
Okay.
She's best known for work in nanotechnology, but she's starting to move into these bigger questions about the universe and studying, physical matter and the flow of time and everything like that. But so here's a quote from her. She says, yes, asking, is this new theory of how reality and universe is structured? She says, yes, you could say so, but above all, it's a theory in which consciousness comes first and structures such as time, space, and matter arise afterward. It's a very ambitious attempt to describe how our experienced reality functions. Physicists like Einstein, Schrödinger, Heisenberg, and Planck explored similar ideas, and I'm building on several of the avenues they opened. She has developed a quantum mechanical model that connects modern physics with non-dual philosophical traditions. The core idea is that consciousness is the most basic component of existence, and that individual minds are expressions of a larger shared field. Like I said, now there are other people who have come up with similar ideas, and this ties into a lot of ancient spiritual and mystical kind of belief systems, like the Vedic idea of the illusion, Maya, the word illusion, and that reality, most of it is an illusion. But if you break it down on like a quantum level, it makes sense, because what we perceive as matter is just energy, and
and what even our reactions or synapses aren't even in real time. They're like a split second or a hair of a second.
Yeah. And there's some like neuroscientists who say that, there is no such thing as free will, because your brain is already deciding things before you actually do it. Although I would say, isn't that you yourself doing it, even though you're not consciously aware of it? But that gets into a whole other.
That's.
But within her framework, experiences like something unexplained or unusual, like telepathy or near-death experiences, are interpreted not as supernatural events, but as possible outcomes of this interconnected quantum field, or a consciousness field, right? She says, my ambition has been to describe this using the language of physics and mathematical tools. Are these phenomena really mystical, or is it simply that there is a discovery we have not yet made, and when we do, it'll lead to a paradigm shift? She compares her proposal to earlier turning points in scientific history. Humanity once believed the Earth was flat and later assumed the sun revolved around the Earth. Both views were eventually replaced by models that reshaped how people understood their place in the cosmos. She suggests that her theory could represent a similar shift. The paper outlines several predictions that could, in principle, be tested with physics, neuroscience, and cosmology. By doing so, she moves well beyond her traditional field, material science, into questions about consciousness and the structure of the universe. I am a material scientist and engineer, so I'm used to seeing matter as something fundamental. But according to this model, matter is secondary, much of which what we experience is representation or illusion, says Strom. And then she connects it to what, I was saying, like ancient things. She says, the texts of the major religions, such as the Bible, the Quran, and the Vedas, often describe an interconnected consciousness. Those who wrote them used metaphorical language to express insights about the nature of reality. Early quantum physicists, in turn, arrived at similar ideas using scientific methods. Now it is time for hardcore science, that is, modern natural science, to seriously begin exploring this. And she wrote her paper is called Universal Consciousness as Foundational Field, a Theoretical Bridge Between Quantum Physics and Non-Dual Philosophy. So it's interesting. I mean, like I said, there's a pretty good book called Stalking the Wild Pendulum by Itzhak Bentov, who was also an engineer and a scientist back in the day, and he talks about consciousness being kind of the underlying field theory. Irvin Laszlo, there's a bunch of other people who kind of have a similar idea to what she's saying, but I always like when more scientists kind of, enter that realm of creating, science from mysticism. It's like the old term, like magic is just science we don't understand yet. It's a similar kind of thing, there could be a lot of laws of physics that we don't fully comprehend, or it's just the way our brain is wired, like you were saying earlier, we have a reaction time for our senses. It takes some, seconds or milliseconds for our brain to process, then give you the information of what you're seeing, in the perception. So it could just be that our brain isn't wired in a way that we can see beyond the veil.
Probably. It makes you wonder, like, when you see, like, a cat get the zoomies or something, like, what are they seeing, like a ghost or something, or some sort of, like, plasma or something? Who knows?
Yeah, exactly. Well, I've been thinking about
ultraviolet ray or something. I don't know.
Well, what if there are, like, what we think are spirits or, whatever, are actually beings that exist they also evolved on Earth, right? But they exist in dimensions that we can't perceive.
Okay.
So we only can perceive 3 dimensions.
Yeah.
But we know, like, space-time is considered like the 4th dimension. We can't really perceive it. We don't really perceive time as a thing other than a measurement, right? But maybe there are beings that perceive 5, 6, 7 dimensions, and they're out of sight. They're in a kind of like a fold within our reality that we just can't see. It's like when you, like, a baby can't perceive 3 dimensions until I think it's like age 3 or something like that, right?
Yeah.
So if that's why, like, the peekaboo game works, right? Because they're like, what happened to that object? What happened to that person's face? It just disappeared behind the hand.
So are you saying that LSD opens up the 4th dimension?
And the 5th. And
the 5th. Wait, what?
LSD is string theory manifested through chemical reactions.
So, yeah, okay, but you're saying that, like, beings that can perceive higher dimensions could be...
Yeah, or they perceive higher dimensions, but they also exist within them. So if we can't perceive a 4th or 5th dimension and they exist in that dimension, they could be walking around among us right now wondering why, we don't see them.
I'm over here.
I'm right here, man.
Have more orange sunshine. You'll see me.
All right, let's see. We got, should we try to do one more? Yeah, I'm going to do one more before we go to break.
But what is time?
What's time, man? It doesn't even matter. Until it's 7 o'clock when we have to end the show.
Yeah, we got to pay our bills,
So there's another one of these new theories of the universe origin, trying to explain the universe origin without inflation. So inflation was at the period I was talking about, the rapid expansion, when after the Big Bang and everything just blew up to a certain point, really rapid. But this was over the course of, like, I don't know, 380,000 years or something like that. But
it seems like a challenge, like, try to describe the universe without inflation. So you can't say that it's expanding. Mm-hmm. It's staying perfectly still.
Well, it's without. It's not that it isn't expanding. It's
Okay.
without the original inflation.
Oh, I got you. Okay.
Yeah. So it's
The
still
origin
expanding.
point.
It's just there was no rapid inflation
Yeah.
in the beginning. And this recent study is published in Physical Review Research. A team of researchers from Spain and Italy proposed a new model for the events transpired immediately after birth of the universe. The study has the potential to challenge longstanding theories regarding the exact processes that occurred at the beginning of the universe. For the study, the researchers used a series of computer models to simulate the beginning of the universe that challenge the long-standing theory that the universe began with a period of rapid expansion known as inflation, with scientists estimating this occurred within the first fraction of a second of the universe's existence. That's one of the most, kind of boggles my mind too, is that, there's this fraction of a second in between the singularity, the Big Bang, and this inflation that we don't know, right? Because we can only see the cosmic microwave background is the picture of radiation that we see from the early stages of the universe. And it's like if that is a wall of particles, right? But we can't see behind it. And behind it would be that fraction of a second before it, which is crazy to think,
It's just the audience watching us, man. That's all it is.
breaking through the fourth wall, man.
No, it's probably some higher being that can watch the whole thing. This is one of the coolest movies I've ever seen. Check out what's going on there.
But it's so, and Itzhak Bentov actually kind of in his book he described the universe. He was using the simile of a seed, like a tree. So if you think of, and this has to do with information theory and everything, but if you think of how everything that exists in a tree, a massive tree, you could take the biggest tree in the world, right? Everything that's in that tree, the branches, the leaves, the bark, the roots, everything existed as information within the tiny seed that was planted. Okay.
Mm-hmm.
That seed is essentially what the singularity of the universe would be. So all information, everything was packed into this little seed of the universe.
Yeah, you're saying what planted the seed?
What planted the seed in the mind of man?
So some theories I've got is it's some sort of alien sneeze.
Okay.
You know what I'm saying? We're just in the moment of the sneeze right now, but we can't perceive time like the alien that sneezed can.
Well, that's funny because I actually do have another new theory that describes the universe as being in sticky fluid.
Okay. Yeah. so there you go.
Like a
Okay.
sneeze.
Another one was this is a giant light show that some king is giving to another king or something.
Okay.
So obviously there's a whole nother level to this thing that we haven't figured out yet, but that's just some theories I'm throwing out there. These aren't beliefs of mine. These are just ideas I'm throwing there. Yeah.
It's or our universe is a competition with another.
Okay.
Whatever gods.
Yeah.
Well, I can create a better universe than you.
Yeah, I got you. Yeah,
There's
yeah,
another
for sure,
one
for sure.
inside of us.
Or maybe it's a mad scientist just went a little bit too far one day.
Mm-hmm.
You put that back.
Right.
I can't. It's expanding.
What if it's a crazy loop where what's happening now is what created the beginning? So with the particle experiments and everything.
Oh, okay.
Like you're saying, some mad scientists or whatever.
Yeah.
But then that's the beginning. We're nearing the end and we don't realize that whatever experiment explodes at CERN or Fermilab or something creates the universe as we know it, and that creates the loop again.
Oh gosh.
All right, but back to this one about the no inflation. In this new model suggests that a long-standing phenomenon of general relativity called gravitational waves are responsible for the universe and all its components, including galaxies, stars, planets, and life on Earth. The team proposes these gravitational waves are part of a long-standing mathematical model called de Sitter space, which is named after Dutch mathematician Willem de Sitter, who worked with Albert Einstein regarding the universe's structure throughout the 1920s. For decades, we have tried to understand the early moments of the universe using models based on elements we have never observed, says Dr. Raul Jimenez, who studies experimental sciences and mathematics at ICREA in Spain. Sorry, it's ICREA. And is a co-author on the study. What makes this proposal exciting is its simplicity and verifiability. we are not adding speculative elements, but rather demonstrating that gravity and quantum mechanics may be sufficient to explain how the structure of the cosmos came to being. So that's interesting. It's just essentially, and now that we have proved gravitational waves exist, and which is very amazing in itself, and it's been 11 years since LIGO, or the Laser Interferometer Gravitational Wave Observatory, initially made that observation, and now has been confirmed by multiple observations of gravity waves. This, proves Einstein right about the kind of the ripples in space-time continuum that is part of the general theory of relativity. So what they're proposing is saying, well, you didn't need the inflation because you had gravitational waves and quantum mechanics that essentially created the underlying fabric of the universe. Now, again, I would say like a lot of these theories are just theories. They haven't been proven. Most of the scientists will say these are what they are, right? They're working models. They're trying to figure things out as we have new and more information. But I think it's just interesting that we're still contemplating all this stuff, and trying to figure out, part of it is to say, ruling things out. You come up with something new, and then you can rule out, like, if this proves not to be right, it only strengthens the Big Bang Theory, right? So you just kind of keep proving, or you prove it wrong. And if you can be the one to prove it wrong, you will be the most famous scientist in all of history. All right, we're going to take a quick break. When we come back, we'll get into is the universe fractal in nature, and is quantum entanglement the actual underlying fabric of the universe? On Think Theory Radio right after this.
My name is Christine, and I'm a widow. My husband, Ryan, was a healthy 34-year-old, and 3 months later, he was gone. Thankfully, he had life insurance. Ethos made it so easy. You can get a quote in seconds, apply in minutes, and get same-day coverage. 100% online, no medical exam. Life insurance didn't take away the loss, but it did give us the space to just grieve.
Get your free quote at ethos.com/save. Ethos.com/save. Paid spokesperson. Time spent on application may vary. Online health questions required.
Chicago's Progressive Talk, WCPT 820, where facts matter.
Welcome back to Think Theory Radio. This is Damien, and today we're talking about some new theories about the origins of the universe, the underlying structure of the cosmos. And one of them, you thought the universe might be a sneeze from a giant entity.
Yeah, some sort of let out. Could
Which
be a
would
fart,
be like
could be a sneeze.
Well, the sneeze one I like because it fits in with this one I'm
Burp.
going to read, because it's like a sneeze and, snot or whatever. It's a viscous fluid.
Yeah.
Right? So this new theory.
So we're trapped in like the mucus and came out of a mucus membrane that creates planets, I guess.
There you go. I like it.
Have we ever really analyzed our snot? There could be a whole galaxy in there. You don't know
There
that.
is.
Yeah, there is. Yeah.
Of like bacteria
See?
and microbes.
Yeah, see?
Well, if you turn the body inside out, it's a whole kind of crazy universe in there, man. They say you go crazy if you flip your body inside out.
Probably would hurt, I would imagine. Probably painful.
You wouldn't be able to understand, man, what you see in there.
I'd imagine I would be a little nervous, though,
Yeah.
Outward nerves. I don't know. Sorry. Stupid. I'll go back to the drawing board on it.
Well, in a paper that was published on the arXiv preprint server, but has not yet been peer-reviewed, I'll let y'all know, Mohammad Ghulam Khawaja Khan, a researcher at the Indian Institute of Technology, suggests that space may possess a property called bulk viscosity. And viscosity is a measure of how much fluid resists flowing or changing shape, like the difference between pouring water versus honey. In this case, we're talking about the bulk viscosity of the vacuum itself, a ghostly resistance that occurs when space expands. Traditionally, scientists have used a simple model to describe the universe, and this model known as lambda CDM. Dark energy, the mysterious force responsible for the accelerating expansion of the universe, is a steady, unchanging background known as the cosmological constant. However, data from the Dark Energy Spectroscopic Instrument, or DESI, not named after Desi Arnaz, which is mounted on the Mayal telescope at Kitt Peak National Observatory in Arizona, released last year, hinted that something may be fundamentally wrong with our understanding of dark energy. And I was reading a little bit into this too as well, and it's showing, so far, preliminary results have showing that dark energy is weakening in the universe, and they believe this is showing that the expansion is slowing down, which goes against previous understandings. So that, just that in of itself has led tons of scientists to come up with all different kind of theories about that. Now, there's a lot of, hardcore dark energy scientists that say, no, slow down. Just because these results say that doesn't mean, it's true. Let's wait for more observations, but these new observations showed a slight mismatch between our standard theories and the actual observed rate at which galaxies are zipping away from us. To explain this discrepancy, Kahn has proposed the model involving spatial phonons. In solid-state physics, phonons are essentially the collective vibrations of atoms in a crystal. But Kahn applied this idea to the fabric of space itself. He suggested that these longitudinal vibrations, which would act as sound waves of the vacuum, could be responsible for a viscous effect that slowed the expansion of the cosmos just enough to match what we see in the sky. See, anytime, you got like the vibrations, crystals, see? People poo-poo that stuff, but it's science, people. By treating the universe as a viscous fluid, this model introduces a drag on cosmic expansion. As space stretches, these spatial phonons slosh around, creating a pressure that opposes the outward push. In fact, the study shows that this simple data-based model fits the DESI data with great precision, potentially solving some of the headaches caused by the standard cosmological constant. And, of course, they're like I said earlier, it's just theory. It's kind of a guess. But viscous dark energy would be a foundational shift in how we view the vacuum of space. And the hard data from DESI is still being analyzed by the scientific community. Like I was saying, slow down. Don't change everything we know just yet. The next decade of data from missions like the Euclid Space Telescope, which is another one of the big ones I was talking about earlier, and continued monitoring by DESI will be the ultimate test. We need more observations to see if these ghostly vibrations are truly ruling the cosmos, or if space is as smooth as we once believed. I kind of hope it pans out just because I like the idea of sound and vibrations being core to the universe, the fabric of the universe.
Mm-hmm.
Because I always thought about that. What if frequencies, sound is what started it all? Like, you think of the singularity, the Big Bang. Have you ever seen or heard of sonoluminescence? It's like when they hit a bubble of air and water with sound wave, it'll turn into light. And they don't really know why. They're still trying to figure it out. But what if that's what happened? Like, there was like this sound wave that hit the singularity, and that's what caused the Big Bang, man.
Okay. It's like the seed was always there. Then one day some sort of sonic.
Mm-hmm.
Maybe it's the combination of the sonic fart. I don't know.
Or maybe it was
the sonic sneeze hit the sonic fart.
Maybe the entity that created it all was like a music producer.
Oh, okay.
And he made this like really deep bass, boom, like an 808 kick, and like boom, and then it hit the particle, and the universe was
dopest album ever.
Let's see, where do we go? Where do we go from here now?
Where do we go?
Well, I guess we'll let's talk to. We're not talking to anybody, but I'm reading from an interview with Michelle Thaler, who is she works at NASA's Goddard Space Flight Center. She's an astronomer and an astrophysicist. And now she has a theory which has to do with quantum entanglement being the fabric, the underlying fabric of the universe, which I like this one because it's kind of, it somewhat ties into the one about, not really about the consciousness thing, but in a sense that everything is interconnected. And basically, you know, quantum entanglement, we've talked about on the show before, but if you're not familiar with it, it is when two particles interact with each other, two atoms or whatever, they will stay connected as a kind of one object. And if you separate them, which scientists have done, they separated them by miles, by hundreds of miles, and they still react to each other. And some will say, oh, that proves, you know, that something's faster than the speed of light. That's not actually what's happening. It's because they are still connected. They're still a single object. And I know it's like, it's hard to understand because we think of things as being separate. You know, we look around the room and you think, you know, your TV is away from, you know, your bookshelf or whatever. But in the quantum realm, everything is much more connected. And so in her theory, she's saying, hold on. I'm reading from her thing, but she's basically, she's talking about quantum entanglement. She's like, it's not a signal traveling because these two things are basically the same quantum system. And the rules of quantum mechanics, they're the same object. So there's no signal really to travel. To a quantum system, there really isn't any such thing as space or time. It will adjust instantaneously because it's the same system. Whether it's microscopic or whether it's many thousands of miles apart, they're the same thing. Could it be that everything is entangled to everything else in some way? She says, I mean, there was once a time when the universe was very small, the time right after the Big Bang, where in a way we were all kind of the same particle. That particle has changed and expanded, but is it possible to think that in some way we're actually the same quantum system to everything in the universe? And what we perceive as space and time is the degree to which we're entangled. We're entangled more to things that are closer to us that have chance to interact with us. The air in this room, that the space that's only outside in my yard, I'm less entangled to things that I've not been able to interact with for much for a long time, things like distant galaxies. I haven't been close to them since the beginning of the universe, she says. Einstein asked, what is gravity really? And now we have to ask, what is space-time really? And we know it can't be as simple as the way we perceive it. Maybe the underlying quantum reality of the universe is that everything in a way it really is still the same quantum system. I've always thought when people think about alien civilizations and they say, you know, flying saucers and UFOs and spaceships, I kind of wonder if the next step in really understanding reality is that there's no such thing as distance. And maybe a very advanced civilization that can somehow manipulate that. You don't have to travel anywhere in a spaceship. You simply figure out how you access this entanglement of the rest of the universe. Could it be that you really are the same quantum system as everything in the universe at once? And that degree of entanglement is what we think of as space and time, as gravity? That's an amazing idea, and it's one that more and more people are starting to look at. Do we know this is true yet? No, this is still conjectural, but the physics is working very well. And one of the promising things is that the equations of gravity emerge now from quantum mechanics. They're no longer general relativity, quantum mechanics, they don't mix. You start with quantum mechanics, and gravity emerges from it from the degree of entanglement. And then she says, so stay put for a couple more decades, we might figure this out. So I thought that was a really interesting concept. Which I've thought about in the sense of, not to get too much onto like UFOs and stuff, but that they didn't actually travel. They don't have ships that travel far distances. They've figured out quantum mechanics to a degree that they can just pop in and out anywhere in the universe, right? Because they're using quantum entanglement to travel through the quantum realm back into the material realm.
Okay.
Right. So, and it's kind of hard to wrap your brain around because the quantum realm is everything that's around us, but we can't really perceive it and we don't really feel it. So if you're trying to explain, well, how do these two atoms instantaneously change without signaling each other? It doesn't, for us, it doesn't really make sense because you think like, well, it has to tell the other one to do something. Like, no, it's still connected, even though we can't see that connection, right? The closest I can think of in our material world to describe it, and I don't even know if this is really the best way or accurate, is I think of like a large body of water, like the ocean, right? You think of an ocean, it's massive, okay? And there's tons of life in the ocean, right?
Mm-hmm.
But we as being, you know, land-dwelling mammals, we kind of look at the ocean as one thing, don't we? We kind of look at it as like this big object. Like the ocean is one thing, and everything within it is kind of reacting to each other. And then they kind of do. You know, you have a fish here or a shark over there, an octopi, whatever, and they, through the movement in the water, they kind of do interact with each other. They can detect each other. They know, you know what I mean?
Mm-hmm.
Because they have that viscosity of the fluid of water as a kind of, you know, overarching.
That's the field.
Their
That's
universe.
it, yeah.
That's the quantum field would be kind of like the water of the ocean. Now, like I said, I don't know if that's a really accurate depiction. That's just kind of the way my mind perceives it, you know, because I kind of see like, yeah, we're floating in this space fluid, you know, so we're all connected. We're all connected, man. Which is actually like, well, these theories, I feel like if more people knew about and talked about in terms of understanding the universe as being so interconnected, I think we'd have a deeper understanding of humanity in itself. We wouldn't, you know, when you think about like the concepts that,
Man, you can't get people to agree on pizza toppings. How are you going to get them to like buy into like one theory on, you know?
well, but that's the interesting thing. If you think about it,
And with like the, you know, 8 billion, 9 billion people on the planet, and how many of them believe that like a God actually takes care of all of this stuff, you know, and can't be budged on that, you know? Yeah,
But
I don't think your
here's the
conversation's going far, man.
but here's the thing.
But
though,
I
if
get you though.
think
I
about-
think it changed some things, you
But
know.
all the religions, essentially, in their core principles, say that everyone is one. We are all one with God. We are all one.
They all say and do a lot of things, Damien.
That is true. No comment. But no, I mean, you know, I just think it's, you know, you think of life on Earth and you think of politics and religion and like class system and money and all these kind of abstract fabrications for us to exist in this world. They're kind of meaningless when you think about the fact that we all literally come from that same seed, that original seed of the universe, you know, and like to look at someone else and think that they're so different from you, it's so ridiculous. And I wonder if that's why a lot of, you know, the aliens that come here haven't really landed yet, because they're just like, what are they? You guys don't even understand that they're the same.
These like Neanderthals down here just not
Let's go to
getting
talk
it,
to the dolphins.
right? Yeah.
All right, we're going to take a quick break. When we come back, we'll get into some more new theories about the universe on Think Theory Radio right after this.
WCPT Replay.
The professor of political science and women's and gender studies at Brooklyn College and the graduate center of the City University of New York and author of Sex Is As Sex Does, Governing Transgender Identity. Yeah, Paisley Curra.
The legislation that they've passed doesn't really speak to any particular problems. Like the legislation that they've passed might be described as like a solution in search of a problem. The legislation covers, you know, school and college participation in sports. And when it comes to like elite sports, that's already governed by the whatever sports associations. They have their own policies and they're working through policies on transgender participation. So it's not necessary for legislatures to weigh in on that. This legislation is really targeting like middle school and high school kids at the non-elite level, and that is where it really just part of enrolling transgender people in the culture wars to create problems where none exist.
Keep listening to WCPT 820 because facts matter.
Because facts matter. You're listening to WCPT 820.
Welcome back to Think Theory Radio. This is Damien, and today we are talking about some new theories about the universe and how everything came to being. Will we ever figure it out? No, we will never figure it out. We'll figure it out a little bit more, little by little, until it all goes away. In the big crunch. Now, what if our universe was born with an anti-universe twin?
What if? Yeah.
That's where the Antichrist lives. No, that's in the White House. My bad. Oh, sorry. The conclusion of physicist Naman Kumar of the Indian Institute of Technology believes that the universe may have been born out of nothing with an anti-universe twin where time runs in the opposite direction rather than exploding from an infinitely small and dense point or singularity like the seed that I was talking about. Kumar writes, in my model, I propose that our universe did not arise from a classical singularity, but instead emerged from a Euclidean phase through quantum mechanics. The essence of the idea is that two branches, a universe and its time-reverse anti-universe, say that 5 times fast, are created simultaneously. Many models of cosmic creation seek to dodge the sticky problem of the initial singularity, at which our current understanding of physics would go out the window. Theoretical physicists James Hartle and Stephen Hawking, for example, proposed that rather than having a strict beginning as we would understand it, the universe evolved out of a no-boundary state in which time and space were intertwined. Alexander Vilenkin, meanwhile, has suggested that the universe instead emerged spontaneously from a state of nothingness via a strange quantum mechanics phenomenon known as quantum tunneling. According to Kumar, however, neither of these models quite explains the birth of the universe as we now observe it. A key element missing from these approaches is the incorporation of a mechanism that naturally accounts for a flat universe, the physicist said. In classical cosmology, spatial curvature plays a critical role. However, observations suggest that our universe is nearly flat. See, the Earth isn't flat, but the universe is flat, man.
So I'm a round universe guy.
Right. Dude, are you? Oh, man.
I mean, doesn't it make sense that they're all moving around? Think about it.
If the planets are round, the universe got to be round, man.
Think about it, right?
Totally.
Makes sense.
This disconnect led me to consider whether another ingredient, specifically a quantum potential, could take on the role normally reserved for curvature. In the quantum realm, the physicist explains, every particle can be described by a wave function that includes both a classical and also a quantum potential. The use of quantum potential in place of a cosmic curvature, he said, allows for a rapid expansion phase early in the universe that would explain the flatness and uniformity we see in the universe today. In Kumar's model, cosmic creation starts with a so-called Euclidean instanton, a phase in which time behaves more like space, which is kind of hard to think about. How does time behave more like space? Time's just space, man.
Time quit being like space. Yeah. Space, you stay over there. Sorry.
Keep them apart. During this phase, the scale factor of the universe, which tells us about its size, follows a cosine-like behavior, he explains. This behavior ensures that the universe emerges with a finite size at the moment time begins, thereby avoiding the infinite densities associated with singularities. According to Kumar, his universe anti-universe model has implications beyond just the birth of our universe, as it may shine fresh light on several long-standing cosmological puzzles. These include the nature of dark matter and dark energy, which are the mysterious hidden phenomenon physicists have proposed to explain the unexpected high rotations of galaxies and the accelerating expansion of the universe. The quantum entanglement between the universe and this anti-universe may be responsible for the mysterious phenomena of dark energy, driving the accelerated expansion we observe today. Additionally, the symmetric creation process could provide insights into the nature and abundance of dark matter, potentially connecting these cosmic puzzles to the very birth of the universe. Now, as study is complete, he's working to refine his cosmological model. A critical next step is to derive testable predictions from this framework, the physicist explained. I am working to identify subtle signatures, such as specific patterns in the cosmic microwave background or in the large-scale structure of the universe, that could validate the universe anti-universe creation process. Which is an interesting concept. I mean, that would be kind of like what I was saying. If there's another, maybe the two entities that created it, One, I'm going to make this universe. Well, I'm going to make an anti-universe. But it's kind of like, positive and negative, and this would explain why we haven't found dark matter, even though we believe it takes up like 80% of the universe. It's because it's beyond that wall. We're talking about that wall we can't see behind. And that wall there's the anti-universe spinning in reverse. That's a wild one. That's wild, man.
And that's where Luop and Niebdiad do the backwards Think Theory radio that I can't think of what that sounds like.
I just hope it's much better. In reverse. It's not that is,
So it's actually good instead of, yeah.
Dun, dun, dun. There's another new theory. I like this one. In a new paper, I like all of them actually, but this one. In a new paper published in Physical Review D, the researchers propose a new model for the origin of the universe, claiming that its formation is the result of a gravitational collapse that generated a massive black hole followed by a bounce inside, which means that our universe may have emerged from the interior of a black hole formed within a larger parent universe. And they are now calling this new model Black Hole Universe. Black Hole Universe.
Yeah.
Won't you come?
Instead of Sound Garden, that's like Sound Field, Sound Landscape, or whatever.
Yeah, Sound Cosmos.
So that's way big. They they're just Sound Garden, just a tiny little garden.
Right.
It's
got a sound. Yeah. What would it be?
Sound greenhouse.
There you go.
Yeah.
We'll go with that.
Sound Arboretum.
Well, this new model offers a radically different view of cosmic origins, which is grounded entirely in known physics and observations. And this comes from an international team of physicists led by Professor Enrique Gastanyaga from the University of Portsmouth Institute of Cosmology and Gravitation. The paper suggests that rather than the birth of the universe beginning from nothing, it is the continuation of a cosmic cycle, one shaped by gravity, quantum mechanics, and deep interconnections between them. See, interconnected. While the existing standard cosmological model based on the Big Bang and cosmic inflation has been successful in explaining the structure and evolution of the universe, it leaves some fundamental questions unanswered. Professor Gastanyaga said, the Big Bang model begins with a point of infinite density where the laws of physics break down. This is a deep theoretical problem that suggests that the beginning of the universe is not fully understood. We've questioned that model and tackled questions from a different angle by looking inward instead of outward. Instead of starting with an expanding universe and asking how it began, we considered what happens when an overdensity of matter collapses under gravity. He continues, we've shown that gravitational collapse does not have to end in a singularity, and found that a collapsing cloud of matter can reach a high density state and then bounce, rebounding outward into a new expanding phase. Crucially, this bounce occurs entirely within the framework of general relativity, combined with the basic principles of quantum mechanics. What emerges on the other side of the bounce is a universe remarkably like our own. Even more surprisingly, the rebound naturally produces a phase of accelerated expansion driven not by a hypothetical field, but by the physics of the bounce itself. We now have a fully worked out solution that shows the bounce is not only possible, it's inevitable under the right conditions. One of the strengths of this model is that it makes predictions that can be thoroughly tested. And what's more, this new model has also revealed that the universe is slightly curved, like the surface of the Earth. See, he's one of your guys, one of the round universe guys.
Mm-hmm.
The black hole universe model does more than fix technical problems with standard cosmology. It offers a new perspective on our place in the cosmos. Furthermore, it could shed new light on other deep mysteries in our understanding of the early universe, such as the origin of supermassive black holes, the nature of dark matter, or the formation and evolution of galaxies. The Arrakis ESA space mission, in which Professor Gastanyaga is the science coordinator, will be transformative in answering such questions and predictions. And it's uniquely designed to detect ultra-low surface brightness structures in the outskirts of the galaxies, regions where the fossil record of galaxy formation and dark matter assembly is preserved. So it's that's a satellite that'll be studying with 4 wide-angle telescopes and observe simultaneously the same region of the sky. Yeah, man. So I like that one. We're inside a black hole. So there's a black hole. Universe emerged inside the black hole and bounced around. And all of that movement and everything created the universe as we know it. So there's like an event horizon around the universe somewhere. That's pretty wild.
Yeah.
That's wild, dude.
It's blowing my mind, man.
One little quick one to end the show with is from a physicist at Heidelberg University in Germany named Astrid Eichhorn. And she's a leader in the field of asymptotic safety, which is a conservative theory of quantum gravity. She proposes that the universe, the fabric of the universe, is fractal in nature. And essentially, because, what we've been talking about is how when you go down to the level of the atomic structures and particle physics, the laws of physics as we know them tend to break down. But what she's saying is that if you go down far enough, so imagine you ever see those patterns, the fractal patterns, like the videos of them on YouTube, and how, you're looking at it and it's zooming in, and it's changing. Then there's that brief instant where it's all the same, right? And then it changes again. Then you're zooming, then it's the same. Zooming, it's same. Zooming, same. That's what she's saying within atomic physics, is that once you zoom down far enough into the protons and electrons and neutrinos and all down in there, that it'll even out, that the laws of physics will become stable again. And then again. Turtles all the way down, man. Fractals all the way down, man.
So is this about the elephants that are carrying the turtles that are carrying the Earth or whatever?
Yes. Yeah. And then they're all in these fractals, and it's like those old drawings with the elephants around. Like, all right, I want to thank everybody for listening. We'll be back again next week and every Saturday, 6 to 7 p.m. right here in WCPT 820 Think Theory Radio.
Stephanie Miller.
I get to say my favorite sentence in the entire world. Here comes Kathy Griffin, hero of democracy. Hello.
How are we going to do this? Because I know we're both going to want to talk at the same time because it's a love fest. I am so in love with you. You are so important and wonderful and funny and brilliant.